Hi everybody, I'm Paul from the Reddick Public Library. Thank you for tuning in. You might know me from Libratory, our weekly hands-on science program at the library. This is our 4th ever online science video and part 2 to our crystal science experiments. And we're going to be doing some more extension experiments today. Last week we made some Epsom salt crystal ornaments, as well as started growing our sugar rock candy, which takes at least a week to form. So we're going to find out just how it turned out today. We will be using hot water again today, so adult supervision is required. Also, these experiments will take overnight cooling again, so a couple of days of overnight cooling is needed as well. In addition to seeing how our sugar rock candy turned out and doing a few more salt experiments, we're going to learn a little bit about crystals, rocks, and minerals.
Today we'll be conducting 2 experiments. First, we're going to make some baking soda salt ornaments, and then we're going to make some table salt ornaments.
Alright, so we have our Epsom salt crystal ornament, and we're going to see just how it turned out after another week of cooling and growing. Alright, well it's pretty similar to how it was last week. It hasn't really grown much more. I think we're going to move on to our sugar rock candy and see just how that turned out. Alright, so here we have our sugar rock candy experiment, and it's been about a week. Full disclosure, I did get a little anxious in the meantime, so I added a pipe cleaner to see how it would maybe grow on that as well. So we have 2 different versions to look at right now and see how they turned out. Alright, ready for the moment of truth? Let's see. Whoa, okay. So it did grow. We definitely got the most growth on our pipe cleaner here, which almost looks like a bundle of grapes or something. So very cool. Even though we didn't get much growth on our skewer, it did grow a little bit. And you could technically eat that. Let me know, guys, do you have any ideas for why it didn't grow on my skewer very well? Did I not roll it in the sugar in the right way? It's possible I didn't let it dry long enough. If I was in the mood to eat this, I could eat it, but I would have to avoid the pipe cleaner, of course. So I just broke off a piece, and you can eat this. This is sugar. Very good. Sugary. I should also note that this jar has a lot of crystals in it. So what I'm going to do is actually pour this into another jar so we can get a sense of how many crystals have grown in this jar. Ooh, and that comes out very syrupy. Alright, so everything that's remaining in this jar is actually in solid form. It's in crystal form, which is kind of amazing. That many crystals formed in a week. Inside of the jar, it's completely coated with crystals. It's almost as if it's like a geode. So messy and sticky and very fun. Alright, so that's our sugary, sticky rock candy experiment. I'm sure there's better ways of doing this, and if I were to do this again, I'm sure that I would make a few changes. But we did get some nice precipitation on our skewer as well as on our pipe cleaner, so this I consider this a success, and it's edible. So hopefully you guys also have success, maybe more success than I did, and get some better looking rock candy. But this I think turned out pretty well, and I think I will enjoy eating it.
So how do sugar crystals form? As we explained in our previous video, our sugar forms a crystalline structure when our supersaturated solution cools, making less sugar soluble in the water, and the sugar precipitates, or comes out of solution. The molecules in common sugar are known as sucrose. Sucrose molecules that come out of solution are attracted to each other through hydrogen bonds and form a crystal lattice of neatly arranged sucrose molecules.
So I hope you guys had a good time doing this, and if you have any pictures that you want to share with us, we would love to see them. And let's move on to our next experiment.
Last week we made crystal ornaments out of Epsom salt, but you could use other salts as well.
You could make crystal ornaments out of baking soda. You could use table salt. You could use kosher salt or sea salt, which are used often in cooking. Or even something like borax, which is a common detergent. Today I'm going to test 2 other salt solutions to see how their crystals form and if they're different. First, I'm going to make a solution with baking soda.
This experiment requires 24 to 48 hours growing time. You'll need 1 adult for supervision of boiling water, 1 large glass jar, 1 pipe cleaner, 1 pencil, water, baking soda. You'll need about a 1/4 cup baking soda for every 1 cup of water, 1 large bowl, a measuring cup, a large wooden spoon, a medium-sized pot, pot holders, and food coloring.
To start, we need to boil some water.
So here we have our boiling water. Please remember, like last time, we'll have to rinse our jar with warm water first to prevent it from shattering due to sudden temperature change.
So what we're going to do first is add some boiling water to our jar, and we're going to do it in 1 cup increments so we can know how much we're adding. So here's 1 cup, 2 cups, 3 cups, 4 cups, 5 cups, 6 cups. Alright, so now we've added 6 cups of boiling water. So for every cup of water, we need 1/4 cup of baking soda. So here's 1, 2. So I got a little reaction there. So I'm going to stir it in as we go. Alright, so it looks like most of it dissolved. I'm going to add another 1/4 cup. 3. Stir it in there. There's 4. Alright, here's 5. And here's 6. Stir it until it all dissolves in, and then we'll see if we need to add any more, because we want to have it all dissolved and then a little bit more. So at this point, it's dissolved as much as it's going to, and there's quite a bit extra that's not dissolving. So it's at a good point where it's definitely a super saturated solution. What we're going to do is put this aside for a second, and then we're going to make our crystal ornament out of pipe cleaner really quick. We've got our pipe cleaner here. You want to make this into a fun shape that will be a nice ornament once it's done. So let's see, what shape can I make? Alright, so I've made a shape for my ornament, and this ornament is then going to be put into the jar attached to a pencil. So before I add this to my jar, what I'm going to do is add a little bit of food coloring to the jar. I think for this I'm going to use yellow. Alright, so now I've got my yellow baking soda and water solution, and I'm going to add my ornament to it, and then we're going to let that cool in the refrigerator for a couple days, and we're going to see how it turns out. So it can more fully submerge, I'm going to actually attach a little paper clip to the end so that I can hang it down right into the water. Alright, so now we're ready to move on to our next salt, our table salt, which I have right here.
This experiment will require approximately 24 to 48 hours growing time. You'll need 1 adult for supervision of boiling water, 1 large glass jar, 1 pipe cleaner, 1 pencil, water, table salt. You'll need about a 1/2 cup table salt for every 1 cup of water, 1 large bowl, a measuring cup, 1 large wooden spoon, a medium-sized pot, pot holders, and food coloring.
So first we're going to boil some more water. And I have a smaller jar this time. This holds about 3 cups of water. So we're going to need about 1.5 to 2 cups of water. Alright, so here we have some more boiling water. Now remember to please coat your jar with warm water first so your jar does not break from sudden temperature change. Alright, so I have 1.5 cups of boiling water right here. I'm going to mix these two together. I'm going to add the table salt a little bit at a time so that I can mix it in as I go. Be patient because it takes a little time for the salt to dissolve. So I'm going to add another 1/2 cup of water. And another 1/2 cup. So at this point I've added about 2 1/4 cups of water, and I've added about 1 cup of salt. It's about 2 parts water for every 1 part salt. Alright, so pretty much all of our salt has dissolved, a little bit left at the bottom. So now that we have our super saturated solution made out of table salt and water, we're going to make our ornament out of a pipe cleaner. Alright, so I've made a star shape ornament, and what I'm going to do is attach it to this paper clip, which will then be able to attach to our pencil and hang into the jar. This time I think I'm going to use a little bit of green. Alright, so then I'm going to add my ornament to my pencil. Alright, so now this is going to have to sit for a couple days so it can grow in the refrigerator. Alright, well it's been about 2 days since we put our baking soda solution as well as our table salt solution in the refrigerator, so let's see if our ornaments have grown. Alright, so here we have our 3 different salt crystal experiments. We already talked about what happened with our Epsom salt crystals, but now we're going to look at what happened with our baking soda crystals as well as our table salt crystals. So first, let's see how our baking soda crystals turned out. Alright, so there's definitely some crystal growth. These crystals are pretty tightly bound, unlike the Epsom salt crystals, which were much more angular and jutting out. Took up a little bit of the color, but not a lot. Maybe I needed to add a little more food coloring. They're tough, I can feel them. So, Very cool. Alright, so this one here is our regular table salt, and let's see how it turned out. So the table salt here did not grow a lot. It did grow a little bit. There is some table salt clinging to it, but I think it might need to either grow a little longer or it's just not going to grow very big. Maybe these are just really small crystals that grow on the table salt ornament here. Different crystals will form from different types of salts. I would recommend you try the borax crystals if you do have borax, because I've seen those grow pretty big. So give it a shot. Alright, so here we have several examples of crystals. We have our sugar crystals, here and here, and we have lots of salt crystals. We've got our Epsom salt crystals here, we've got our baking soda crystals here, and we've got our table salt crystals right over here. So all of these formed crystals out of supersaturated solutions. But there are many ways that crystals form, and different types of crystals. When you think of crystals, what comes to mind? Diamonds? Sapphires? Rubies? Those are all crystals. They're a little bit different than what we have here, because we have sugar crystals, which are actually organic, so they're not minerals. We also have our salt crystals, which are actually minerals. So in what ways are our sugar rock candy and salt crystal ornaments here similar to regular crystals that you might think of, such as diamonds or sapphires? Let's take a closer look. Alright, well, I don't know about you, but I love to collect rocks and minerals and crystals, and I've pulled out my old rock collection here. I've got my little mineral and fossil box. I've got a lot of my different rocks displayed here.
The study of crystals is a subfield of geology. Geology is the study of the earth, its processes, and the materials of which it's composed. There are many fields in the study of geology. The study of crystals is known as crystallography. The study of rocks is petrology. Minerals is mineralogy, and gemstones is gemology.
So do you know what the difference between rocks and crystals is? What a mineral is? Generally speaking, minerals are the building blocks of rocks and crystals.
A mineral is a naturally occurring, inorganic, or non-living solid with a definable chemical composition with distinct physical and chemical properties and an orderly internal crystal structure. Common minerals include quartz, feldspar, mica, calcite, and even salt. The number of minerals known to exist is disputed, but estimated to be between 3,000 to 6,500, with new varieties discovered every year. Some compounds are known as mineraloids because they don't fit the exact scientific definition of a mineral. Some are synthetic or man-made, such as cubic zirconia, synthetic sapphires, and industrial diamonds. Others are organic, like amber, which comes from tree resin. Sugar crystals aren't technically minerals either because they come from plants like sugarcane. Other compounds lack an orderly crystalline structure, such as opals, glass, or even obsidian, which is a type of volcanic glass used in arrowheads. And still others have variations in chemical composition, so they are also considered mineraloids.
Here's one of my favorite crystals. This is a raw amethyst crystal. It's actually made up of purple quartz. So it's very beautiful, and it's shiny and purple and great. Here's one of my favorite rocks. It's granite, and it's made up of feldspar and quartz. Rocks are an aggregate or a collection of minerals. They are generally mixtures of two or more minerals, like granite that I just showed you, which is multicolored and made up of grains of quartz, feldspar, and mica. Show you that again. Some, such as marble, are actually a collection of a single type of mineral. In this case, that's pure calcite.
Rock types are divided up into three main groups based on how they're formed: sedimentary, igneous, and metamorphic. Igneous rocks are the result of magma or lava which is cooled and solidified. Sedimentary rocks are made up of layers of sediment which have accumulated, often underwater, over time, and the mass becomes compacted and is eventually cemented together, but the process can take millions of years. An existing rock, which undergoes a profound transformation caused by heat or pressure, is known as a metamorphic rock. During the process of metamorphism, the specific arrangement of minerals is altered and their individual crystal structure may also change.
Crystals are also a collection of minerals. What makes crystals unique is their highly ordered crystalline structure. This here is one of my favorites. It's known as citrine, and it's actually a yellow quartz. I have a lot of quartz in my collection because I like it. This here is clear quartz, And these are rose quartz. And here is some yellow quartz.
The scientific definition of a crystal is based on the microscopic arrangement of atoms inside it, called its crystal structure. A crystal is a solid where the atoms form a periodic arrangement, a three-dimensional repeating pattern known as a crystal lattice. Crystals are commonly recognized by their distinct shapes, consisting of flat faces with sharp angles. However, just because something is shaped in this way doesn't mean it's necessarily a crystal. A crystal is scientifically defined by its microscopic atomic arrangement, not its macroscopic shape that you can see. Crystals often form in nature when liquids cool. Molecules in the liquid gather together in uniform repeating patterns as they attempt to become stable. In nature, a common way crystals form is when liquid rock, called magma, during metamorphic or volcanic processes, cools. If it cools slowly, then crystals may form. Many valuable crystals, such as diamonds, rubies, and emeralds, are formed this way. Quartz crystals often form as superheated silica recrystallizes as a result of cooling magma. Quartz is the second most abundant mineral on the Earth's crust. Quartz can be found in many forms such as clear quartz, amethyst, citrine, and agate. Clear quartz resembles ice. Fun fact, the root for crystal comes from the Greek word kristallos, or ice, because the ancient Greeks believed that clear quartz was ice frozen so hard it could not melt. The purple color seen in the mineral amethyst is the result of impurities of iron, while the yellow color in citrine is often produced by heating amethyst. Natural citrine is quite rare. Agates are made up of microscopic quartz crystals and come in many colors. Quartz is composed of silicon and oxygen atoms. The atoms are linked in a lattice of triangular tetrahedra, with each silicon molecule attached to 4 oxygen atoms, and each oxygen atom being shared between 2 tetrahedra triangles.
One particularly beautiful type of rock formation is known as a geode, and that's when you have crystals that form inside of a rock. So I'll show you an example of that. Here is a little crystal geode, and I don't know if you can see inside of it, but there's actually little crystals in there. Here's another one, and here's another, and here's another one.
A geode is a somewhat round rock which contains a hollow cavity lined with crystals. The mineral lining the cavity is often clear quartz, atop multiple bands of agate. Some more rare geodes can contain purple amethyst, white calcite crystals, blue gem silica, or even opal. Rocks which are completely filled with small compact crystal formations are called nodules. The only difference between a geode and a nodule is a geode has a hollow cavity and a nodule is solid. What about diamonds? Diamonds, composed entirely of carbon atoms, are one of the most precious stones on Earth. The atoms are linked in a cubic lattice where each carbon atom is surrounded by 4 other carbon atoms with covalent bonds, making it incredibly stable and strong. Diamonds are the hardest natural substance, and they're used as cutting tools in many industrial processes. However, due to its luster and rarity, diamonds are probably best known as a highly precious gemstone. Fun fact, have you heard that diamonds come from coal? This is a common misconception. While diamonds are composed of carbon, coal has rarely, if ever, played a role in the formation of diamonds. In fact, most diamonds have been dated to be much older than the Earth's first land plants, which is where coal comes from. Diamonds are formed deep in the Earth at high temperatures, around 2,000 degrees Fahrenheit or so, as well as high pressures in the mantle, and they come to the surface by volcanic eruptions. The carbon source for these diamonds is most likely carbon trapped in the Earth's interior at the time of the planet's formation. When a piece of a rock or a crystal is cut and polished to be used as jewelry, it becomes known as a gemstone. A stone must meet certain criteria to be officially classified as a gemstone. Attributes like color, durability, beauty, and rarity, which also help determine its value, though an interesting history can also add to that worth. It takes great skill and artistry to cut gemstones from crystals. Gem weight is measured in carats, or 0.2 of a gram. The Oppenheimer diamond, at around 254 carats, is one of the largest uncut diamonds known to exist. The most famous diamond of them all, most likely, is the blue Hope diamond, which is deep blue and it's 45 or so carats. and it's surrounded by many, many more diamonds suspended from a platinum chain with many more diamonds. The Hope Diamond is believed to have formed more than 1 billion years ago. It is believed to have surfaced in India in the 1600s as a massive blue diamond weighing around 112 carats, sold to King Louis XIV of France. The king had the gem recut and set as a pendant as part of his crown jewels. It was later stolen during the French Revolution and resurfaced in England in 1812 in its current form at around 45 carats. It was purchased in 1830 by Henry Philip Pope, a London banker and gem collector, and eventually made its way to the Smithsonian, where it stays currently. Special thank you to Trish for sharing these photos with us. You might find quartz, marble, or other interesting things around your home. If you do, share them with us.
All right, well, thank you for joining me. I hope you had some fun making some crystal rock candy as well as some crystal salt ornaments. I hope you learned a little bit about crystalline structure and the different types of crystals that there are, as well as the differences between minerals, rocks, and crystals. If you've got pictures of your rock collections at home, or if you have pictures of your ornaments or of your rock candy that you made, please do send them in because we'll post them right to our blog. We would love to see them. All right, thank you. Have a good day. Bye.
Here's Elliot's collection. Thank you to Elliot for sharing it with us.
Bon appetit.